So what we're doing today is systems. We're still doing systems of equations. But the ones for today are multivariable linear systems. Specifically, we're going to be looking at 3 variable systems of equations. Row echelon form and back substitution. So row echelon form is a way to solve these 3 variable systems of equations, and the whole goal is to get one equation, go from our starting problem to one equation with 1 variable, one equation with 2, and at least one with 3, and then solve backwards. Because once we find the value of z, scroll back down, once we find the value of z, we can plug it into the equation with y and z to find y. Once we get y and z, we can plug it into the first to find x and work backwards. So like this here, they gave us what z is. We have it set up in this form. Well, z is 2. So for us, that means that we can take the equation y plus 3z is equal to 5 and replace the value of z. Replace z with its value, which is 2. And solve for y. Well, 3 times 2 is 6. Subtract 6 from both sides, telling us y is -1. Well, we have z. Now we have y. So the only variable we're missing is x. So we can take the first equation, x minus 2. Well, we found out y is -1 plus 3 times 2 is equal to 9. 2 times -1 is positive 2. 3 times 2 is 6. 2 plus 6 is 8. Tells us x is 1. So the solution is the point 1, -1, 2. And that's it. Questions on this here? Substitute in, we got -1. Substitute back in, we found our order triplet. Gaussian elimination, this is how we would do it by hand. We can interchange, multiply, add, or subtract. So the process is to get it in that stair-step form. So we would take these equations and we want to get one equation with x, y, z, one with y, z, and one with z, or one with one variable. And we would do this by adding or subtracting the equations. So the first thing we could do, and you don't have to write all this out, is we'd look at the top equation in the middle, and if we add those 2 equations together, I'll extend that a little bit so it's a little higher up. Well, the x plus -x would be 0. -2y plus 3y is y, plus 3z equals 5. Then we could add the other 2. Get this here set up, and we can continue to work this out till we get it in this form. Now, the other method is to take this starting equation, and we can use the graphing calculator. We just have to set it up as a matrix. Now, the matrix we're going to want, we're going to take the coefficients across the top. 1, -2, 3, 9. -1, 3. There is no z value, so it's 0. -4, 2, -5, 5, 17. Now, we've done this before. We've done this in Algebra 2, solving these way and solving them by matrices. -1, 3, 0, 4. negative 4. 2, negative 5, 5, 17. Okay. So let's get the graphing calculator. Now the first thing we're going to want to do is type this in as a matrix. So we're going to go second matrix, over to edit. We want a 3 by 4, and we're going to type our numbers in. 1, negative 2, 3, 9. And then negative 1, 3, 0, negative 4. 2, negative 5, 5, 17. Second, quit. Second matrix. So we're going to go over to edit, and what we're looking for this one here is REF. Second matrix, as we put it in as A, we can have it do this here. So it gives us it in the stair-step method, and we can work our way back. It's telling us that Z is 2, X or Y plus 5Z is 9, X minus 2.5 Y plus 2.5 Z is equal to 8.5. Although, if we go back over to math and go to RREF, second matrix A, this here gives it in a little better form, because it tells us what X, Y, Z is. X is the top, Y is the middle, Z is the bottom. Over here. Over here. So RREF gives us the final answer. REF gives us a form that we have to plug back in. One, negative 1, 2. Look back at the calculator. 1, negative 1, 2. It solves it. It's going to be easier and better to do these by REF. Questions on this here? Do not know. Now, with systems of linear equations in 2 variables, solutions of the linear system and equations in more than 2 variables must fall into one of 3 categories. Either there's exactly one solution like we had, there's one set of points, or a point that all 3 cross. There are infinitely many, or there are no solutions. That's going to be one of these 3. No solutions means that they don't cross or intersect at all. Exactly one means we have exactly one point, and infinitely many, we have many that will work. One solution for a 3 variable system is going to look like this here. One point or one line. Solution, we can also have one plane, or those are none. These 2 kind of fall into the infinitely many, because any point on that line is going to be a solution. There's an infinite number of points on a line, so we do have infinitely many. As well as a plane, there's infinitely many points on a plane. But these last 2 are no solutions, because there is no point that intersects all 3 that will make all 3 equations true. So they're going to fall into one of these 3. And especially if we're looking at this as a matrice, this will give us a point. Our infinitely many, we're going to have a line in the matrix that's just going to be all zeros. If we have all zeros, that is true, and it means that there's infinitely many. With these no solutions, we're going to get a line like this here at the bottom, which is just saying that 0 is equal to 1, which is a false statement, meaning that there is no solution. And the other thing we'll look at is non-square systems. So non-square system, the number of equations differ from the number of variables. And a system of linear equations cannot have a unique solution unless there's at least one equation. So for these here, These are our non-square. We have 3 variables, but only 2 equations. These work a little differently because we won't have a set point for a solution. We will have infinitely many. But at this point here, we can do this with a matrix. We take the coefficients after we have lined up our variables. So for us here, we take the coefficients going across the top, which gives us 1, -1, 1, -2, 1, 2. And on the bottom we have 2, -1, -1, 1. And this is the matrix we can type in. The calculator, the graphing calculator, does make this a lot easier to work with. So we can go second matrix, edit, and we can edit the first one. For this one here, we have a 2 by 4. And going across the top, we have 1, -2, 1, 2. And we have 2, -1, -1, 1. Questions on how we type any of this in? So what we're going to do next is second matrix. Over to math, and we're going to find our REF, second matrix A. And what we get is this here. So we get 1, 0, -1, 0. And on the bottom we have 0, 1, -1, -1. This is what we started with, and our answer, 1, 0, 1, is what we got. Now we have to put the variables back in to understand what we're looking at. So we had x, y, z is equal to our numbers. So for the first equation, we now have x plus 0y minus z is equal to 0. The bottom equation, we have 0x plus y minus z is equal to -1. But really, we can look at these two equations in the form of, well, the first one is x minus z is equal to 0. And our bottom equation is y minus z is equal to -1. Now, both of these equations are in the form of here, xz, yz. And for both of these here, what we're going to do is solve for the non-z value. So for x, we're going to add z to both sides, saying that x is equal to z. For y minus z equals -1, we'll add z to both sides, telling us y is equal to z minus 1. Because again, we will have infinitely many solutions, and most all of these are going to end up in terms of z. For our point, our value, because z, for us here, can be any number. It's just a number. Z is just a value, or we can just call it A, we can just call it Z. So for our solution here, really we're going to be looking at the point Z, Z minus 1, and Z. Because for any value of Z, this ordered triplet, Z, Z minus 1, Z, will give us a solution that works for all three. So we plug the original one into the calculator and take our REF of it to get this here, which helps us find this infinite set that works. So they work it out by hand, x equals z, and we get this here. Now they used it in terms of A, but this is the same as this here. And any value of z or A, will give us a solution for this. So if we picked z to be 2, well, we'd have 2, 2 minus 1, and 2, which is just 2, 1, 2. That there would be a solution. If we picked that z is negative 9, we'd have negative 9 minus 1, negative 9. This here would also be a solution. This here defines any solution from a given value for z. Questions on this here? Okay. That's it. So problem number 7, they're giving you solution pairs. They just want you to plug them into each equation and make sure that they are a solution. 14, solve that system of equation. 22 through 30 even, solve those systems of equations. You can use the graphing calculator to solve those. Same with 37, 39, and 43. Yep.